My name's Gabe Degani. I work at Samsung on the Xclipse GPU team for the Exynos. We released our first Xclipse with the Exynos 2200. And during this process, we decided not to use a native GL driver. Instead, we decided to use Angle. So I wanted to talk about that journey with everyone and say, what were the positives, what were the negatives? Why did we decide to do it? And, where are we going? I don't know if they'll lean over. Is this better, or can someone turn it up? Usually nobody says I'm not loud enough.
Oh, that's sorry. Try that.
Hello, hello, hello. Better? Okay, cool. My wife definitely says I'm definitely loud enough. It's fine. Agenda, Angle. We'll go through the agenda, but I have this for people later. Before I start, I'd like to do acknowledgements. I did not write a single line of code. I am doing the less important work of helping run the team, but I did want to say thank you to the Google Angle team. They helped us at the beginning, and then the Samsung Angle team strewn across the world. They did most of the heavy lifting, including the US with my team, UK with Ralph and team, India and Korea. So we had quite a few groups working on this, and I just want to say thank you. Everything I did was pretty amazing. So I stole a couple of old Angle slides from Jamie. So what is Angle? Like Elon said before, it's a layer on top of Vulkan, or on top of any kind of API, but in our case, we used Vulkan to do OpenGLES. So OpenGLES goes in, and then you can have any one of these APIs come out, but for us, we just focused on Vulkan. And the typical, another Jamie steal. So we stole this one. So code is like a layer cake. I was gonna subtitle this as Vulkan as a HAL, which is a common theme and something that's pretty interesting with how low level Vulkan can be. You can map quite a few things to it. In this picture, you can see that we're treating the Vulkan backend as the entrance into the actual driver, and then we're mapping everything from GL to that Vulkan, which is self-explanatory. So I want to talk about the process and what the stakes were for for the Samsung team. When we started with our most recent GPU exploration, we had a partnership with AMD. And we have an RDNA-based collaboration working with AMD for the Samsung GPU on the Xclipse. So when we started this, we looked at everything and we tried to reduce our total cost of ownership across the board because our team was not as big as we would have liked it to be, and we needed to definitely just hone in on the important things and make sure we could reduce efforts in other areas. One of the ways we decided to do this was by having Angle, because we understood that we were going to upstream and open source everything we did. And if we can solve GL, which is basically in maintenance mode, and have that be in great shape on top of Vulkan, then, and it is upstreamed and open source, then, I mean, more or less, we would consider it a solved problem. Then it would decouple from the hardware, and we could focus most of our energies on Vulkan as it related to the hardware itself, which is a much nicer, much cleaner problem. So like I said here, it says it allows IHVs like Samsung to focus all our graphics efforts on Vulkan. It means that not only our software architecture team, but our hardware architecture team could just map to a single API. Lots of new features that are coming are only going to be in Vulkan, like you've seen in previous presentations, ray tracing, VRS, a few other things. Anything that you're seeing that's coming down that's exciting, that's going to migrate probably from desktop to mobile, is going to be on Vulkan only. So that's another reason to put most of your eggs into the Vulkan basket. We did find, and I'll be honest, very few situations where having Vulkan underneath GLES actually improved performance intrinsically. MIP map generation improvements, finer grained barriers, pipeline caching, all are improved by having GL on top of Vulkan. But for the most part, I'll get to that later, but conformance debugging of GLES is also simplified. So you're decoupling your GL implementation from your hardware. And so as long as you have a Vulkan conformant driver, your GLES is also conformant. That's a pretty exciting statement. I just want to say that one more time. As long as your Vulkan is conformant, your GL is conformant. That's exciting. I mean, and especially in a situation where you have to ship a phone every year, and you have to get through all of these conformance tests and DEQP and all these things with Android, man, that's a no-brainer. Lastly, I'd say that one of the benefits of using Angle is you're reducing the attack surface on the hardware. You're only having a single Vulkan driver, permeate all of the layers through the kernel, and then the GL is acting as an application layer. Okay. So up to the right, you can see that the legacy mobile driver stack, we support Vulkan, GL, ES, and OpenCL. OpenCL is not a first-class citizen in Android, but we still have to support it because of our multimedia, camera, and display pipes all require certain kernels to do some post and pre-processing in OpenCL. And that's kind of the de facto choice for a lot of our camera buffs. And so Samsung has dozens and dozens and dozens of OpenCL kernels, probably hundreds. And to convince the rest of Samsung to say, no, 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 move to Vulkan Compute, it's a tall ask right away. And so we still have to support OpenCL. So what are the costs of using Angle? I don't want to say this is all sunshine, but the trade-off, hopefully, that I'll convey by the end is that it was worth it. Not all GLES features are, at this point in time, directly translated to Vulkan, which means there is some emulation required. One example is, just like camera requires OpenCL for certain things, camera and multimedia live and breathe and speak at YUV, and then obviously GPU mostly speak RGB, right? So doing things like render target and YUV is not native to Vulkan, and definitely the Android hardware buffer interactions were not as nice and clean as we would have liked them to be. So we're going to work with Khronos to make YUV a first-class citizen as well. Second, performance overhead can obviously reduce application frame rate. This is just a way of saying, yes, it does cost something. You are translating a layer at runtime into a different language. There is a cost. Most of that cost is in compiling. So if you do offline compiles, a lot of that cost will go away. But there is an overhead. I'll have slides on that. But one thing I would say is that most phones, any kind of GPUs have 20, 30% year-over-year improvements. The kinds of costs that we're talking about should be absorbed in the very first year. And so if you renormalize your performance based on your own angle, you can still see those improvements. You absorb that cost once. Pipeline creation introduces additional delays. This is kind of what I was saying, where creating pipelines and compiling shaders is going to be the most costly part. So the productization journey. So when we first started this, when we started the Eclipse project, it was about 2019. And we were looking at this, and it was in pretty good shape, mostly a Chromium effort to get Angle into where it needed to be. Our DQP 2.0 pass rate, which if you look at the overall number of tests was 2/3, was at 90%, which wasn't bad, but the 3 and 3.1 in EGL were very low. Our perf, when we first started this, was about 50% of native, which was unacceptable. And so I'm just giving like a baseline of where we started in 2019. But by the end of 2022, we have a fully conformant, like Alon said, 3.2 driver on our Vulkan stack. Everything we needed to get to the latest and greatest OpenGLES with most of the extensions required for a flagship phone, we were able to get and meet or exceed most of the expectations for a GLES stack on phone. Some of the extensions that were required to support GLES 3.2 should be kind of obvious, like transform feedback, YCBCR conversion, like I said, YUV, Android hardware buffer, device memory purport, swap chain. Most of these things are common. They're in the baseline. Maybe some of the YCBCR are not, but for the most part, most of these were public and they were available, and we had to support a few more, but not too much. A couple of the ones that were particularly tricky were shared presentable memory, shared presentable image, and that was required for things like the S Pen, where you had to write on the frame buffer you were reading from. So that was a little bit tricky, and then doing that from GL through Vulkan was also pretty tricky. We had to have a few workarounds. We're still working with Google and with Khronos to come up with some first-class YUV extensions for Vulkan so that we can map GL YUV target. I think I said that wrong, but whatever that one was. YUV image rendered image target to Vulkan. Okay. But with the Angle team, they have, and this is an old number, they have at least 175 traces running in Conformance and making sure that the stack is fully loaded. So it's not just a science fair project, but it's actually running the majority of the apps in the App Store. So this is good news. This is not just CTS conformant. This is real life app and game conformant. The performance story for productization at the beginning, the only thing that really ran at the time, this is why we're using GL Mark II, was that because with all the extensions that we supported at time 0, this is something that just ran out of the box. And basically the story from this graph is averaging all of these out, we're about 60 to 70% of native GLES performance on on GL Mark II. And so that's just kind of giving you a stamp measurement. So what did the Angle teams do to address the performance gaps? A lot. They fixed memory pooling. They fixed pipeline compilation with default state. They replaced the mipmap generation using the AMD Open SPD library. They avoided depth stencil image clear. Did a lot of LRU-based eviction. Deferred acquisition of swap chains. I mean, they fine-tuned a lot of the things that you would want to using profilers and making sure we can get to as close to native as possible. This is probably the bang chart. Similar to what Alon said in the previous presentation, for the majority, 2/3 of the apps were within 10% of native. That's a pretty exciting statement to say that you have a free GL driver. The remaining apps are still being worked on. This is a 3 to 4 month old snapshot. This isn't speed of light in any way. I don't want to say this is where we will land, but based on 3 to 4 months ago, there's constant work being done. We're hoping to push this entire graph up 5% at least. And so that's a pretty good story. For this graph, each dot is an app trace. 100% is parity to native. The last thing I'll say about this is that getting to native is important for PPA for phones, similar to you've heard in previous presentations. We're more concerned with sustained than we are with peak, because if you ran peak for more than a minute or 90 seconds, your hand would burn and you'd have a little Samsung logo, burned into your hand. And so we're very conscious of the heat thermals. And so, and most of the games in the App Store, if I'm honest, don't require peak, don't require a whole lot. They're Angry Bird level, and we do focus quite a bit on the really high requirements games, the Call of Duty-ish type games, the UE4, UE5 type games. But we're hoping that those games will just go to Vulkan anyway. They'll bypass GL. GL is a legacy checkbox that we're hoping to solve using something with only 5 to 10% overhead. So I'm actually maybe more excited than you are about this. I think this is mission accomplished plus plus. Most recently in the last year, they've done quite a bit to improve the compilation flow of Angle. It used to have a 5 or 6 kind of step process using the SDK GLSLang library. They were able to remove that GLSLang, which actually used ASCII strings in the middle of it to compile GL or Vulkan compatible GL AST all the way to SPIR-V. With the latest flow, it's much more reasonable and only 2 steps, where we go with a ESSL to the Vulkan compatible GLSL AST to SPIR-V. Lots of deduplication, a lot of improvement in app startup time because most compilations happen on the front end. And also a reduction of code size of the Angle library and the cache because of all of these reductions of steps. So that was really great work. And I'm almost done, so I know you guys want your coffee. Future work, and I think you could probably see where I was going. This is kind of an obvious lead. We're also looking into translating OpenCL, moving CL on, either doing CL on VK or maybe doing a CL over as a front end to Angle. We're looking into both of them. We've been working with the CLSPV library, and right now the CLSPV library is 95+% conformant with everything we need it to do for CL onto Vulkan. And this is with an OpenCL 3.0 driver. So hopefully very soon, we'll be able to say at Samsung that we have both Angle and CL as translation APIs on top of the HAL that we call Vulkan. That's all I have. Any questions? Yes. Sure. Okay, I'll repeat my summary of your question. The question is how is GL being deployed, or how is the expectation for Angle to be deployed as the GL primary driver? The answer is it's already deployed in the S22 Galaxy phone with the Exynos 2200. There is no GL native driver. When you launch a GL app in the system folder that contains all of the other .so drivers, Angle is there already. So it is deployed. It is being updated with the OS updates. It's in the field. So there is no deployment. The exciting part of Angle that we haven't really talked about is if there is a bug in Angle, you could probably, if you're a game developer, deploy your own version of Angle with the fix inside the same folder as your game, and it would read that in its application level, and it would just translate to the Vulkan directly, and you can fix your stuff without waiting for an OS update. Or you could use game drivers from Android if that's what your platform is. So hopefully that answered your question. Okay, well, thank you very much. Oh, sorry, one more. I didn't take the numbers. I'll have to get back to you on that. So I don't even want to speculate. I was given a pretty graph. I used it. Yes.
I'm just curious. Did you notice how much your memory is tracked out shader CM or there's a bunch of static variables that it likes to initialize.
I'm going to speculate. I think I had, well, let me look at the slide. I'll look at the slide with you. I think it said 3x code reduction. So I don't know where that 3x started from, but let's just say 3 times. And I don't know if that was overall or just in the sections that they were using for shader cache.
Yeah, back in the day when you started up with your backend, it was funny because after the first compilation that you did, so I think maybe it was good across, but it was a situation where you had basically just like 3 megabyte memory spike that went away.
So I know that there's additional work to be done with, and I'm talking adjacent to what your question was. And I'm sorry, the question was, did I notice a large memory, or did the Angle team notice a large memory decrease in getting rid of GLSLing? I responded with, I think there was a 3x improvement, but I don't have the absolute numbers. The thing I would like to say, maybe to respond to that, is that there's still extra work with the GL shader extensions that are going on in Vulkan that are being talked about to further reduce the extra caching of both the GL, the GL pointed compiled binaries as they get translated into SPIR-V. So there is still work to just store the SPIR-V with some kind of hash and have that go all the way through Angle and be able to save in the duplication of having both GL shader objects as well as Vulkan shader objects in the same application stack. So there's still work to be done, but I think we're moving in the right direction, and where we are today is pretty healthy. Yes. So, yeah. So if you go, the question is the 3.2 conformant Angle already upstreamed? The answer to that, I believe, is yes, but on the website, they only really mention 3.1 because their outward conformant is done on Swift Shader and they don't support geometry shaders. But I believe that if you downloaded the Angle, built it, and then you ran it on a Vulkan driver with the appropriate extensions, it would be 3.2. We at Samsung, we're trying to be 99% plus convergent with the upstream. We're only really keeping back things that don't make sense to be in the open, like we'll call them post-silicon improvements for our device in particular. But we're trying to, the whole point of the effort for Angle is to reduce this ownership. And if we diverge the branch too much, we would be shooting ourselves in the foot. Yes?
Do you take advantage of pipeline libraries in Angle?
We are planning to. I know that's in talks. If we are currently, I'm not sure. I'd have to ask my Angle team. I'm more of the talking head. The question was, are we planning on using pipeline objects in Angle libraries? Okay. Well, thank you. Coffee break.